When news breaks in the Bitcoin world, oftentimes it's hard to understand. This week, a vulnerability was revealed in the Android operating system that put a real fear in the Bitcoin community. LTB host Andreas M. Antonopoulos spoke with Andreas Peterson of the Mycelium Wallet project about exactly what happened. But before we get to that, Andreas, I had some questions for you. First off, in the interview that follows, you talk a lot about entropy. Can you explain to me what that is in sort of simple terms?
Sure. Entropy is a measure of how much information there is in a message. If you look at it the other way around, how much randomness there is in a message in computer science terms. In physics terms, it's essentially how much disorder there is in a system or how much energy in the form of heat there is in a system. But in the case of information systems, really you can say entropy is saying the same as randomness. So the problem we're discussing in this particular bug is that something that should be random, that means it should have high entropy, is not random. It doesn't have the necessary entropy. In fact, it's a rather predictable sequence.
So when we talk about randomness, that can also be characterized as noise compared to the signal, right?
Well, effectively, yes. If you have a random stream, especially if it's a secure random number generator where you expect it to have certain characteristics of randomness, then there should be no signal. That's the definition. So you should have every bit that comes out of that should be noise. You should have no signal.
So it's all noise then. Okay, so if it's all noise, then is there a difference between a lot of noise in a system versus a little noise in a system? Just not necessarily talking about random number generators, just broadly speaking. If you're trying to encrypt something or secure something, is it better to have more randomness than less randomness?
You need absolute randomness. Let me give you an example. Let's say that there's a function within the system where you're taking a random number and you're multiplying it with your secret key. So for simplicity's sake, let's say I have a secret key and my secret key is 3. So give me a random number between 1 and 50.
35.
Fantastic. So I'm going to multiply that by 3 and I've got my digital signature. Now, if I ask you in my next transaction, give me a number between 1 and 50.
17.
Okay, great. So you gave me a different one. But what if you had said 35 again? And I had then multiplied that by 3 and broadcast it to the network. And people knew that they could guess that if you'd said 35 once, you were likely to say 35 again. Well, then they can just divide by 35 and figure out what my private key is. They wouldn't be able to do that if you actually came up with a random number. So that's the problem. The problem is you should say something different, but you say the same number again.
And so that's more likely to happen in a system that has less entropy than one that has more entropy. Is that right? Because there are fewer possible numbers?
So the way it works is when you have a secure cryptographic random number generator, you can only pull out bits for the amount of entropy it has. So let's say, for example, it has currently 128 random bits to give you. If you get 128 random bits, those will be random. If you try to pull out 200 bits, the first 128 will be random, but after that, the system doesn't yet have enough entropy. You have to wait a bit for random processes to occur. The basic concept behind it here is this was not a problem of running out of entropy. This was simply a broken algorithm. So it was supposed to give out 256 bits of entropy, and instead it gave out on average 9. So the difference there is that instead of having, more choices or probabilities than there are atoms in the universe, it came down to 500 combinations. That's 9 bits of entropy. So, you can very easily test all 500 combinations and pretty much figure out what the next random number that's supposed to be random is. And if you can guess the next number, well, it's not random.
So what should have taken all the supercomputers, that are currently in existence in order to crack this one particular 256 degrees of randomness, basically.
You could do on a whiteboard with a pen.
Right. Okay. Well, that makes a lot of sense. Okay, great. Well, I really appreciate you providing some clarity for us on this issue. Let's jump right into the interview with the other Andreas.
Hi, everyone. This has been a rather exciting week in the Bitcoin space with the announcement of a very critical Android bug that has widespread repercussions all across the mobile wallet space. To discuss this in a bit more detail, I'm very pleased to be joined today by Andreas Petersen, who is one of the owners and authors of the Mycelium mobile wallet, and he's here to talk to us a bit about this recent breach.
Hello, everyone.
Hello, Andreas. Thank you so much for joining us. Can you tell me a bit about what exactly the problem is? Where did this start?
To see the source of the problem, we have to go back in time a little bit to 2012, when there was an announcement of a randomness failure in the Android implementation of Java, basically in the Harmony system. And this was presented at the RSA conference in 2013, I think it was March. This was merely an academic problem because nobody could really see the practical problem behind it, except for this weird randomness behavior on Android.
So it would only really apply if you had some kind of bizarre digital currency that somehow could be stolen, right?
Yes, yeah. So most people don't really notice if, let's say, their SSL connections are not really that secure, or if they encounter some other kind of problem. So Bitcoin really puts the system under test here and reveals these kinds of problems. To be precise, I think this is not a single problem. There are two very distinct problems that we are seeing here. The first problem is, there is a so-called random device in most Linux systems, or in all Linux systems. And from that, there is a urandom device. And these seem to be working fine, as far as we know.
So the operating system level random device generator that creates random numbers, that's working okay on Android.
Yeah.
Okay.
So to actually use random numbers on Android using the Java language, you need to instantiate a so-called secure random object. And that secure random object is just a wrapper for a system library. And that is commonly implemented using OpenSSL. And that implements the randomness by talking to the device. And so there are many layers involved here. Wallet authors did nothing wrong. They stuck to the documentation and applied best practices to not rewrite your own cryptography and so on. So that was not the problem. The problem was in between all these layers, entropy was removed from the original entropy source, that is the random device.
So basically, you're getting numbers that are less random than they should be from the source. So gradually, they're getting less and less random. Okay.
Yeah, but from that bug directly, nobody really lost money. I've talked to another guy who is like cracking private keys as a hobby. And he generated lots and lots of random numbers, 2.6 million random numbers, and he never got a collision using Android. He never got a collision, so there was no private key, let's say, compromised as far as we know. We don't know really. But what we do know is that there is a second issue. That is, when signing transactions, there is also a random number needed to generate a valid signature. And that signatures are definitely not as random as we think they are.
So let me just clarify there, Andreas, for a second. So the issue is not with the key generation per se. The issue is when you try to sign a transaction, essentially to spend it, you are in a situation where you're seeding that signature with a random number, which is not random. And if you do that more than twice, that can reveal the private key. Is that correct?
Yes, exactly. So there is an equation. It is described very nicely in a Bitcoin Magazine article. If you have this random number and you use it twice, then using this equation, you can trivially simply calculate the private key that was used. This means that if you have a weak random number generator, then that can potentially expose your private key to everyone. That has happened a number of times in the past. Most of the time was when people were playing around with toy implementations, prototype implementations of clients. But it also happened on Android directly when signing transactions. The issue is that you create a new secure random instance and then you query it twice. And on a very weird circumstances, there are fallback scenarios where the entropy goes down to a level where it has a very high chance of repeating the same value. Basically, I think that in some cases, the randomness can go down to 9 bits. of entropy instead of 256 bits of entropy.
Given all of those circumstances, I would assume that means whether you've generated the key on an Android wallet or not, if you have an Android wallet that is using this Java secure random number generator and you use that to spend money at any time, you have a chance of having revealed the private key for that particular wallet?
Right now, I would assume, of course, you should migrate your keys because of the general entropy issues. But right now, if you haven't lost your money yet, it's not extremely likely that you will lose it in the future because of this second vulnerability. Because that would mean if you continue using the old software and generate these weak transactions, yes, then you could potentially expose that. But that's very unlikely.
So one thing that was rather interesting with this was that the bug itself expresses itself on the blockchain in a way that anyone can then go and find these suspect transactions. Presumably, you're looking at a transaction, or rather, you're looking at two consecutive transactions done by a same key where the same random parameter R was used for both. And presumably you can just write software that trawls through the blockchain to find these, right?
Yeah. People were doing this, and you will lose your money rather quickly if you generate such a transaction.
If you'd already done it, you would have lost your money already, so there's nothing to worry about. Just don't make any new transactions.
Yeah, and of course also change your keys. There are many properties of this stack, SSL and the Android API that are kind of shady, in my opinion, because it certainly isn't impossible to implement that in a way that it would simply work. And it's kind of shady that it fails in such a way. So I would say if somebody used secure random on Android for any purpose, that you should change your keys, because there might be a vulnerability that we don't know exactly about yet.
So, Andreas, would you say that this Bitcoin demonstration makes the 2013 announcement at RSA much more critical and concrete now, and should therefore lead other developers on Android doing software that's not directly related to Bitcoin, but to other secure implementations? This will kind of wake them up. You know, this is now in the wild and usable.
Yeah, I don't really think it's a very big coincidence that all these bugs happen together. There's a kind of conspiracy theory here. But of course, this bug makes it potentially much easier for anyone with massive computing resources to crack encrypted communication.
Right.
And therefore, everyone who is the author of any cryptographically interesting application on Android should definitely cease to use secure random and rather look for an alternative. So the most obvious alternative would be to access the dev-urandom device, dev-urandom file directly and read from that, as we do now in the Mycelium wallet. The other thing is that I'm currently looking into an implementation proposal by Bruce Schneier, if that will provide a very, very good alternative, even that we could combine multiple entropy sources.
Ah, right. Yes. As a developer of the popular and very functional and useful Mycelium wallet, you've taken steps now to fix this problem. I'm assuming all of the Android Bitcoin wallet developers are doing so. What would the users experience? Would they experience simply an update coming through their Play Store?
Yeah, so first of all, I have to really give credit to Jan Möller, who did a tremendous job in working over the weekend, and he really is a fabulous developer here. Thanks to him.
Thank you, Jan.
As far as I know, all popular Android wallets have been updated. So there are 4 wallets out there that are keep your own private keys on the device. That's a Bitcoin wallet from Andreas Schildbach. Mm-hmm. That's Mycelium wallet, Blockchain Info, and also the now kind of, I would say, deprecated Bitcoin Spinner. That was the previous application from Jan, was also updated. So on some of these wallets, you need to manually do the key rotation. But on others, for example, on the Mycelium wallet, there's a wizard that detects old keys and automatically moves them to new keys. And in the process, well, what I really want to emphasize here, please do make a backup of all your old keys and your new keys. You don't know if you're going to need them in the future. In the wizard, it also gives you the opportunity to make a backup. So please do that and get those private keys onto a piece of paper, please.
Okay, yes, very good advice. Get it onto paper wallets as backups. So let me just clarify a tiny bit. You talked about the rotating keys. If we were to break down this process, you download the new code from the software developers who have updated the code. You make a backup of the keys, as you very rightly just said. Then you create a new wallet, and then you essentially send all the money from the old wallet to the new wallet. Is that it, pretty much?
You will send the money from one address to another address.
Okay.
And your wallet software now has maybe both addresses in it or just one address in it, depending on the implementation used. It's not a very complex problem. You're just essentially just sending money to yourself, and it's on a new address.
Okay. And very critically, I would say this has to happen after the software has been fixed, because if you just generate a new address and try to send your money, you will be creating exactly the kinds of transactions that could compromise your private key, right?
Yeah, so the updates for all the wallets have been pushed out to the Play Store and also to other channels. That shouldn't be a problem. Can I ask you something in return regarding this topic? You were involved in the paper wallet project, yeah? How is the situation there? Do you have any inside information? What kind of randomness does the paper wallet provide you?
The original paper wallet is derived from the bitaddress.org version 2.4. That's the same software we use for Open Paper Wallet, Safe Paper Wallet, and as far as I know, it's also the Bitcoin Paper Wallet, which is another version. All of those use the operating system dev-urandom from within a JavaScript wrapper library. I don't know. That does not run on Android, so that would be inside the desktop browser. As far as I know, there's no vulnerabilities there.
It would rely on the JavaScript implementation of the browser used. So it could be Chrome or Internet Explorer or something, whatever.
Well, it's cross-browser, so it operates on all of them. Yeah. But certainly, yes. I mean, that's one of the considerations here, and I think a good security practice. And one of the reasons I was not as worried about this, even though I use a mobile wallet, is simply that I only had 2 to 3% of my funds online on the wallets that were doing transactions from my mobile client. The rest was all in paper wallets, and that's a good way to be rest assured, essentially, to be relaxed about it.
Yeah, absolutely. So also, I mean, on paper wallet, you rely on having a good entropy for the key, of course, but the main problem that duplicated random values in the transaction doesn't even show up in paper wallets because they don't do any transactions, of course.
That is correct. Although we do have in our latest version of the Safe Paper Wallet software, we do have a way to completely sweep and redeem, and it will create a transaction. So I would have to look at the random number generator. But in general, I think this is really a sign of things to come, because vulnerabilities in the past had time between going from theoretical to practical and in the wild. But what Bitcoin does is it provides immediate incentive to take that theoretical exploit practical and make some money off it. So we're going to see this happen more and more, would you say?
Absolutely, yeah. So this is really showing the weaknesses on some systems, and also in computer security. It's not surprising that a lot of file hosts, server hosters have been hacked, and the attackers specifically went only for their Bitcoin customers and left everyone else alone. So this really shows the security status of a system if you have some Bitcoins up for grabs for an attacker.
Most systems are not quite ready yet for storing digital money, but we're going to learn and develop as time goes by. I would like to thank you so much, Andreas Petersen, co-author of the Mycelium mobile wallet, for giving us some excellent information today on what exactly is happening with Android random number generator, how to solve it, so what to look out for, and thank you so much for all this useful information.
You're welcome.
EasyDNS is the Swiss Army knife for your domain names, helping meet their customers' individual needs since 1998. EasyDNS has been an outspoken critic of SOPA and CISPA. EasyDNS was an early supporter of Bitcoin, and now they are proud to sponsor this show. Do business with a company that shares your values. Get a 13% discount when you pay with Bitcoin. Go to bitcoin.easydns.com and be sure to use discount code LTB.